Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2023, paper 2, variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. In the last video, we have discussed from question 1 to question 10, and in today's lesson, we will start from question number 11 and we will try to finish all the remaining questions from this paper. Let's study together, let's improve together. Question 11 says a machine has a power input of 200 watts and a useful output energy of 1 kilojoule in 6 minutes. What is efficiency of the machine? So in this case, simply first of all we can draw the machine. So here we have machine. Input power is given to us, so simply we can draw the arrow. Input power P in is given, that is equal to 200 watts, and P out, first of all useful P out we need to find out. Useful P out, and useful P out simply will be equal to energy over time. So in this case we have energy that is equal to 1000 joules, and we need to divide by time taken. Time taken is 6 times 60 because 6 minutes. So if we solve this one, we will get 2.7 watts. Now we need to calculate efficiency. Percentage efficiency simply is equal to useful P out divided by total P in, multiply by 100. So in this case we have P out useful, that is 2.7, and we have P in, that is equal to 200 watts, and we need to multiply this one by 100. So if we solve this one, our answer in this case has to be equal to 1.4%. So the answer for this question is C. Question 12 says, what is the unit of power? Unit of power is watt. So first thing you need to understand, unit of power is watt, and the symbol we use is capital W because this is after name of scientist. Now if you get given option joule, this is unit of energy, so this is not correct option, so this is incorrect. Newton, this is unit of force, so this is also not correct. Volt, this is unit of EMF, or we can say this is unit of PD, potential difference, so this is also not answer. So D is the right answer. This is unit of power. Question 13 says the diagram shows a rectangular block of weight 16 newtons. It is resting on a flat surface. What is the pressure at the base of the block due to its weight? So base of the block, so we need to calculate P. So P simply is equal to F over A, and F in this case is equal to mg, is equal to weight of the block, and the area in contact with the table. So this is the area in contact with table, so we have to divide by this area. So this is 4.0 centimeters, so we have to use unit centimeters because in the given answers we have centimeter square, multiply by 5.0 centimeter. Weight of the block is already given to us, that is equal to 16 newtons, so simply we have to divide by 4 times 5. So the answer for this question will be 0.8 newtons per centimeter square. So the answer is C. Question 14 says an oil tank has a base of area 2.5 meter square and is filled with oil to a depth of 1.2 meters. The density of the oil is 800 kg per cubic meter. We need to find out what is the force exerted on the base of the tank due to the oil. So first of all we can draw a tank. So you can imagine we have a cylindrical tank. So this is the tank. So we can imagine we have a cylindrical tank. So this is cylindrical tank. Base area of this tank is given, that is equal to 2.5 meters square. We can also imagine it has oil inside. So here we have oil inside. So this is oil. Depth of oil is given, that is equal to 1.2 meters. So this is 1.2 meters. We need to find out force exerted at the base of the tank, means at this base. So the force at the base is simply equal to weight of oil. So this is equal to weight of oil, and weight of oil is equal to mass of oil times G. So force in this case simply we can write down is equal to rho times V. Rho is the density of oil and V is the volume of oil times G. And density of oil is given to us, that is equal to 800. And volume of oil we can write down 2.5 means the base area multiplied by depth. And value of G is very important one. For in new syllabus, value of G you have to use 9.8. So it's very important, 9.8 newtons per kg according to new syllabus. So you have to use G is equal to 9.8, not G is equal to 10. So we have to multiply this one with 9.8. So if we solve this one, our final answer will be equal to 24,000 Newton. 24,000 Newton. So the answer for this question is D. So your answer will be close to this one, maybe a little bit plus minus, but if you write down up to 2 SF, your answer has to be equal to 24,000. Question 15 says a sample of gas is trapped in a rigid container. Rigid container means that fixed volume. So this is the point you need to understand. Rigid container means volume is fixed. So we can say fixed volume. As the temperature of the gas is increased, the pressure increases. Which statement is not correct? The gas molecules have greater kinetic energy. Yes, kinetic energy of gas molecules increases if temperature of the gas increases. The gas molecules hit the walls of the container harder. Yes, because molecules are moving faster, so they will hit harder. The gas molecules hit the walls of the container more frequently. Yes, because their speed is faster. Means speed is greater, they're moving faster, so they will hit the walls more frequently. So this one is correct, this is correct, this is also correct. The gas molecules move further apart. No, because volume is fixed, so they will not move further apart. Volume is fixed. Volume fixed, it means that this one is incorrect. So the answer for this question is D, because we need to find out which one is incorrect. Question 16 says what happens when the temperature of a liquid increases? For option A, it is given to us the mass of the liquid increases. Mass will not change. If you increase the temperature of the liquid, mass will not change. So option A is incorrect. Mass of the liquid increase, option B is also incorrect. Volume of the liquid increases, yes. If it is not a rigid container, volume of the liquid will increase. So this one is correct. Making the liquid less dense, because molecules will move further apart. So less dense means that molecules move further apart. So molecules will be further apart, so the volume of the liquid will increase. So option C is correct. Volume of the liquid increases, yes. More dense, no. More dense means molecules get closer to each other. So this one is incorrect. So the answer for this question is C. Question 17 says a bar of metal which is a good thermal conductor is heated at one end. What is the main method of transfer of thermal energy along the bar? Bar is a metal, so we can write down it's a metal, and in metals energy is transferred by lattice vibrations and also by electrons. Main method of energy transfer in metals is electrons, because metals are good conductor because they have more free electrons. That's the reason metals are good thermal conductor. In non-metals, energy is transferred by lattice vibration as well, but in metals is due to lattice vibrations and also due to free electrons. So the main method of energy transfer in metals is due to free electrons. So if you look at option A, this is not correct. Movement of atoms do not move at all, so this is also incorrect. Transfer by electron, yes, because main method of energy transfer in metals is by electrons. Metals are very good thermal conductor because they have a lot of free electrons. So this is correct answer. Question 18 says a transverse wave moves along a rope. The diagram shows the positions of the rope at one particular time. which two labeled points are one wavelength apart. Wavelength is the distance between two consecutive same points on the wave. So if you look at point X and if you look at point Y, they are lambda by 2 apart, and if you look at Y and Z, they are also lambda by 2 apart, means lambda by 2 half wavelength. So the distance between X and Z, this distance, because these are the two same points, two consecutive same points, so the distance between these 2 points is equal to lambda. So the answer for this question is C. Question 19 says light in transparent plastic meets a boundary with air. Light is transmitted into the air only if the angle marked theta in the diagram is greater than 36 degrees. What is the refractive index of the plastic? So in this case, first of all, we need to draw normal line. So we can draw the normal at this point. So this is the normal. So in this case, this angle is a critical angle. So we can say this is theta C, because this angle is 90 degrees. So critical angle is angle with normal. And this angle is already given to us. This is equal to 36 degrees. So the critical angle, this one has to be equal to 54 degrees, because 90 minus 36 degrees, this is equal to 54. Now simply we need to use Snell's law. So we can write down, in this case, NP means for the plastic, sine of theta C, the critical angle in the plastic, this one has to be equal to N air times sine of theta in air. So sine of theta in air, mean this is refractive angle. So this is incidence angle. So NP we need to find out. Sine of theta C, we have sine of 54 degrees, but N for air is equal to 1, and sine of 90 degrees, this is also equal to 1. So we can rewrite this one, NP times sine of 54 degrees, this is equal to 1 times 1. So we can write down NP, this is equal to 1 over sine of 54 degrees. If we solve this one up to SF, we will get 1.2. So the value of refractive index is equal to 1.2. Question 20 says a thin converging lens has a focal length f. An object O is placed to the left of the lens as shown in the figure. Where is the image formed and how does its size compare to the object? So the first thing we need to understand, in this case, object is placed between the lens and the focal length. So the image has to be, in this case, image has to be virtual and it has to be larger than size of the object. Virtual, larger than object, and also on the same side, and also image has to be on same side. So these properties you need to understand. If you understand these properties when the object is placed between lens and the focal length, then simply we can find the answer. So in this case, opposite side, no, this is wrong. Opposite side, no, wrong. On the same side of the lens as the object and larger. So the answer for this one is C. D is also incorrect because this part is right. Size is smaller. This is wrong. But we can also verify this one with ray diagram. So simply we can draw this line here. So we can draw this ray diagram. And we can extend this one to the focal length. So it has to pass through the focal length. So this has to pass through focal length. We can also draw another ray that is passing through the center of the lens. So we can draw like this. These two rays, they will not intersect each other. But if we draw the extension of these lines, so if we draw the extension, we can draw extension from here. So if we extend these lines, they will meet here. So we can also draw the line from here, the extension of these lines. If we draw, they're gonna meet somewhere here. So now if you look at image will form at this point. You can draw the arrow for that, image in this case will form at this point, and this image is on the same size and this is larger, and this image is virtual because it is formed by extension of the rays. Extension, so these are extension of the rays. Extension mean actual light is not here, so this is formed due to extension of rays. So this image is virtual. So the answer for this question is C. Question 21 says, which diagram shows what happens when a ray of white light passes through a prism? So if you look at option A is incorrect because light has to disperse. So it doesn't disperse in glass, so it means this one is incorrect. If you look at B, light has to bend towards normal. So this is telling you bending away from normal. So this part is wrong. If you look at option C, this part is correct, but this part is wrong because when light will enter from glass into air, it has to bend away from normal. So this one is incorrect. If you look at option D, this one is correct, this part is also correct. So the answer for this one is D. It's a typical question. You need to understand how light behave when it passes through glass prism. So the answer for this question is D. Question 22 says a television station transmits a signal to a television receiving dish. The television has an on and off indicator light. The television is switched on by a remote control which changes the indicated light from red to green. Which electromagnetic wave used in these actions has the longest wavelength? Longest wavelength. So first of all, we need to understand what is this electromagnetic wave, means what kind of wave is this one. So this one is a radio wave. So this is radio wave. So here we have visible light, so green and red, these are visible light, green and red visible light, and this one is infrared. So you just need to understand infrared. So which one has the longest wavelength? Radio waves, they have the longest wavelength. So the answer for this question is A. Question 23 says a student makes a list of some applications of waves. 1. Medical scanning of soft tissue. 2. Sterilizing water. 3. Using sonar to calculate ocean depths. Which application use ultrasound waves? The first one, for scanning of soft tissues, ultrasound are used. So we can say ultrasound are used. Ultrasound waves. And for water, for purification of water, we can use UV light. And for ocean depth, in sonar, ultrasound waves are used. So we can write down ultrasound. So the answer for this question is C. Applications of ultrasound waves. 1 and 3 only. So the answer is C. Question 24 says the diagram shows a bar magnet at rest on a smooth horizontal surface. A length of soft iron wire is held parallel to the magnet. The wire is released. What happens? So in this case, we need to understand soft iron. This is a magnetic material. And magnetic material is only attracted by magnet. Only attracted. So we can say only attracted by magnet. So only attracted. Only attracted. So it simply means that in this case, it will move towards magnet. Move towards magnet. So this is the concept you need to understand. So if you look at given options, it is given to us moves away, incorrect. The wire moves towards the magnet. This one is correct. And C is also incorrect and D is also incorrect. So the answer for this question is B. Question 25 says which diagram shows the electric field pattern and direction around a positive point charge. For positive point charge, we need to understand electric field lines point away from the positive charge, because if we place a positive test charge will experience repulsive force. So the electric field lines have to point away from the positive charge, because these lines are telling us force on positive test charge. If I place a positive test charge here, force on this one will be away from the unit positive charge. So the electric field lines have to be in this direction. So we can also draw electric field lines here. So electric field lines point away from the charge, positive charge, because these electric field lines are telling us direction of force on unit positive charge. So the answer for this question has to be A. B is incorrect because this is for negative charge, and C and D, they are incorrect. Question 26 says a laboratory has a standard wire of known resistance. It also has other wires made from the same material as the standard wire but of different lengths and diameter. Which wire would definitely have a resistance of less than the standard wire? So simply you need to understand for this one, R is equal to rho L by A. Question is asking you less resistance. Resistance will be less if the length is shorter, area is larger, because in the question it is given to you they are made of the same material, means the resistivity is the same. So this one is the same. Longer wire? No, it has to be shorter. So the answer can be C or answer can be D. Wire diameter. Wire diameter has to be larger because area is equal to pi by 4d square. So we can also write on here rho L divided by pi by 4d square. So D has to be larger. So the answer for this question is C. This is incorrect because this is telling you smaller. So this will increase the resistance. So this one is incorrect. Question 27 says the graph shows the relationship between the current in a circuit component and the potential difference across it. The graph has a straight section and a curved section. What happens to the resistance of the component in these two sections as the current increases? So first of all, in this case we need to understand gradient of this one, gradient of IV graph, gradient of IV graph is equal to I divided by V, and this is equal to 1 over R. So simply we can rewrite this one. We can say gradient is equal to 1 over R. R, we can say R is equal to 1 over gradient. 1 over gradient. So if gradient decrease, if this gradient decrease, it means resistance will increase. And if gradient remains same, it means resistance remains same. If gradient remains same, it means resistance remains same. So these 2 points we need to understand. Now we can also draw the line. So if you look at first part, so in first part gradient is constant. So we have constant gradient. So gradient is constant. So it means resistance is also constant. No change in resistance. Now if we go to the second part, if we go to this part, second part means this part. So this is curved and the gradient is decreasing in this part. Gradient is decreasing. So we can write down gradient decreases in this case. So if gradient decrease, it means resistance will increase. So in the first part resistance remains constant. So this is not possible answer. This is not. No change in resistance. This one is correct. The resistance decreases. No, resistance is increasing. So this is incorrect. So the answer for this question is D, because no change in resistance. Resistance increases. So the answer is D. Question 28 says the diagram shows part of a circuit. What is the combined resistance of the circuit? So in this case you can see we have two resistors, they are connected in series, and these two resistors, they are connected in parallel with this one. So we can redraw this circuit. So in this case we can replace these two resistors with one resistor of 3 ohms. So we have one resistor here. So we have another resistor of 4 ohms that is connected in parallel with the previous one. So we can make it little bit proper. So we can draw here in this case this wire, and we can draw this wire. So this is a wire, and the resistance of this resistor is 4.0 ohms. Now these two resistors, they are connected in parallel. So we can find out R total. In this case, this will be equal to the product of these two resistance, means you have to multiply, then you need to divide by sum of these two resistance. So we have 4 times 3, this is equal to 12 divided by 7. So if we solve this one, our answer in this case will be equal to 1.7 ohms. So the answer for this question is C. Question 29 says the diagram shows a circuit which includes two resistors and a battery. The voltmeter reads 6.0 volts. What is the potential difference across 30 ohm resistor? So the first thing we need to understand, in this case, these two resistors, they are connected in series. So current is the same. So if we have value of current, we can find out potential difference across this resistor. So we can connect our voltmeter here. We need to find out reading on this voltmeter. In order to find reading on this voltmeter, we need value of current because we have value of resistance already. So then we can plug in value of resistance, value of current here, and we can multiply this one with given resistance, and we can calculate value of PD across this resistor. So first of all, we need to calculate current, but for this resistor we have resistance and we have potential difference across this one. So we can find out value of I will be equal to V divided by R, and this is the potential difference across this resistor. Value of PD across this one, we have that is equal to 6.0 volts, and resistance of this one is 10. So the value of current is equal to 0.6 amps. Now simply we need to plug in here 0.6, and if we solve this one, our answer will be equal to 18 volts. So the answer for this question is C. Question 30 says a wire is moved down in a direction perpendicular to the magnetic field. Three changes are suggested. The speed of the movement of the wire is increased, the magnetic field is decreased, direction of the magnetic field is reversed. Which changes increase the electromotive force induced in the wire? If you look at first change, speed is increased. If we move the wire faster, it means we have more mechanical energy that will be converted into electrical energy. So in this case, EMF will increase. If you look at second option, magnetic field is decreased. This will decrease the EMF. Direction of magnetic field is reversed. This will have no effect on the magnitude of EMF. It will just change, it will just reverse the polarity of EMF. So it will have no effect on magnitude of EMF. So the answer for this question is B. But one thing you need to understand, by electromagnetic induction, we only transfer mechanical energy into electrical. If we have more mechanical energy, we can convert into more electrical energy. So that's the reason when we increase the speed of the wire, EMF will increase. Question 31 says a wire is moved across a magnetic field. This causes an induced current in the wire. The induced current interacts with the magnetic field to produce a force on the wire. In which direction is this force? So first of all, we can answer this question just by understanding of conservation of energy. So when we move a wire in a magnetic field, there will be induced current. And due to induced current, wire will experience a magnetic force, and that force has to be opposite to direction of motion of the wire to conserve energy, mean according to law of conservation of energy. So if you have this understanding, simply you can choose this answer. So the force, magnetic force on the wire, has to be in the opposite direction to the movement of the wire to conserve energy. If the force is in direction of motion of the wire, it means there is free energy. So wire will get faster and faster, and more electrical energy will produce. That is against law of conservation of energy. So this is one thing. If you have this one in your mind, you can simply choose the answer. But now let me explain you this one a little bit in detail. Imagine that we have magnetic field that is into the page. So simply we can draw magnetic field that is into the page. So this is magnetic field, this is into the page, and we have a wire. So you can imagine that here we have this wire. So this wire we have here, this wire, and we move this wire to the right. We move this wire to the right. If we move this wire to the right, magnetic field is into the page. So you have to use right hand rule to find direction of current in this wire. So you have to use right hand rule. So you have to use right hand rule. So in this case, magnetic field is into the page and the force is to the right, so current will flow upwards. So this is direction of induced current. Now we have a wire and the wire is inside the magnetic field, so wire will also experience a magnetic force. Now you have to use left hand, so we will be using left hand. So you have to use Fleming left hand rule. For left hand rule, we can see there is current that is upward, so I can draw direction of current, and magnetic field is into the page, so I can draw here magnetic field that is into the page. So this is magnetic field, so you have to use left hand. Current is up, magnetic field is into the page, and current is up, so the force in this case will be to the left. So this force is in opposite direction of motion of wire, so this one we can say is the magnetic force, or we can say this is the opposing force. So this force is always in direction opposite to the applied force, so this is opposing force. So this is the concept you need to understand. I hope this one is clear to you. So the answer for this question is D. Question 32 says a 100% efficient step-down transformer has primary voltage Vp and primary current Ip. Which row compares the secondary voltage with Vp and the secondary current with Ip? So in this case, we are talking about step-down transformer. So first of all, we can simply draw a step-down transformer. So here we have step-down transformer. Step down. So here we have primary voltage, so we can say this is Vp, and we have Np here, and we have Ip, primary current. On other side, this is step down transformer, so we can draw here step down. So this is Vs, and there is current Is, and we also have Ns. Step down transformer simply means that Vp has to be greater than Vs. So Vp has to be greater than Vs. And the second thing now we need to understand, this is 100% efficient transformer, so we can say Vp Ip, power input and power output, they are the same, so Vs Is. So if Vp is greater than Vs, so it means that if Vp is greater, so Ip has to be lower. So in this case, Vs is smaller, so Is has to be greater. So question is asking which row compares the secondary voltage. So secondary voltage, you can say Vs, it has to be less than Vp, and Is, it has to be greater than Ip. So these 2 points you need to understand, these 2 points. So Vs has to be less than Ip, so this one is not possible, this is not possible, this can be possible, greater than Ip, so Is has to be greater than Ip. So the answer for this question is C. This one is incorrect. So this is how you can figure out. So this is the best way to answer this problem, because it is given to you 100% efficient transformer, so the power input has to be equal to power output. So this is step down transformer. Step down transformer simply means that secondary voltage has to be lower than primary voltage, and then you can figure out current. Question says the scattering of alpha particles by a thin metal foil supports the nuclear model of an atom. Why are alpha particles used rather than neutrons? So we need to understand nucleus is positively charged, so we can write on here nucleus is positively charged. So if we use neutron, they have no charge, so there will be no repulsive force, so we cannot determine the size of the nucleus. So that's the reason alpha particles are used, because alpha particles, they have positive charge. Alpha particles, they have positive charge, and neutrons, they have no charge. If we use neutron, they will just go straight through, so it will be very hard to determine the size of the nucleus. Neutrons, no charge, they are neutral, no charge, so they are neutral. Because they always travel more slowly, that's not the reason. Because they are heavier, that's not the reason. Because they are larger in diameter, size doesn't matter. Because they have a positive charge, so that's the reason we used alpha particles instead of neutrons. So the answer for this one is D. And nucleus is positively charged, so they will be repulsive force. So we can determine the size of nucleus. Let's try to understand a little bit more in detail. Before nuclear model, there was a plum pudding model, and this model was suggested by J.J. Thomson, plum pudding model. According to this model, whole core of the atom has a positive charge, means the positive charge was evenly distributed. So in order to test this one, Rutherford did experiment and he used alpha particles because it was suggested by plum pudding model that positive charge is evenly distributed in the atom. So he used alpha particles, so there will be repulsive force because alpha particle is positively charged and the core of the atom is also positively charged. So he used alpha particles, not neutron, because if neutron there will be no interaction. So that's the reason alpha particles were used. Question 34 says an iron nuclide is represented by the symbol shown. Which statements about a nucleus of this iron nuclide are correct? The nucleus contains 56 neutrons. Actually 56 is number of protons, mean this is representing the mass number of protons plus number of neutrons. And in this case there are 26 protons and there are 30 neutrons. So this statement is incorrect. The nuclear number is 30. No, nuclear number is the mass numbers and mass number is equal to 56. So nuclear number is equal to 56. So this one is incorrect. This one has to be 56. The proton number is 26. Yes, proton number is atomic number. So proton number, we can also say this is atomic number. And atomic number is equal to 26. This is atomic number, so we represent with Z, and this is the mass number, so we represent this one with A. So the answer for this question is, in this case, D. Yes, this is only correct statement because this is incorrect, this is incorrect, so the answer for this one is D. Question 35 says a sample of a radioactive isotope has an initial rate of emission of 128 counts per minute and a half-life of 24 days. How long it will take for the rate of emission to fall to 32 counts per minute? So in this case we have half-life and we have initial count rate. So simply we can write on here initial count rate. So we have initial count rate that is equal to 128 counts per minute. After one half-life, this one will be equal to 64, and after another half-life this will be equal to 32. So we have one half-life here, so this is T1/2, and time taken will be equal to 4 days. After 4 days, count rate will be 64 counts per minute, and after another 4 days this will decrease to 32. So the time taken is equal to 4 plus 4, time taken will be equal to 8. Question 36 says several scientists are working in a laboratory. The scientists are experimenting with sources which emit ionizing radiation. Each scientist is given a list of safety rules. 3 of the rules are shown. Keep at least 2 meters away from other people. Do not stay longer than 4 hours per day in the lab. Stay behind the lead line screen. Which safety rules are for protection against the effects of ionizing radiation? Against the effect of ionizing radiation. So if you look at first rule, keep at least 2 meters away from other people. This is not protection against ionizing radiations. So this rule is incorrect. Don't stay longer than 4 hours. If you stay longer, it means the ionization, the radiation dose, it will be very high. So you should not stay longer than 4 hours. So this one is correct. stay behind the lead line so you can protect yourself from gamma radiation. So this one is also correct. But this is not a safety precaution for an individual. And so that's the reason this one is incorrect. So in this case we have 2n theories. So the answer for this question has to be D. So this will increase radiation dose. So let me write on here. So this will increase radiation dose if you stay longer than 4 hours. And this one will protect from gamma radiations. Gamma and also other type of beta and alpha as well. Question 37 says, which data is needed to calculate the average orbital speed of a satellite around a planet? So orbital speed, V orbital, so we can say V orbital, this is equal to 2 pi r over d. In this case you need to understand what is r. This is the distance from center of the planet, we can say distance between center of planet and center of satellite, between center of planet and center of satellite, center of satellite. So this point is very important, you need to understand. Center of satellite. So we can also sketch this one. So in this case you can imagine this one is the planet and let's say here is the satellite. So we need to calculate orbital speed of satellite. So in this case r is representing distance from the center of the planet to the center of satellite. So this one is the capital R, and capital T is representing time taken to complete one cycle. So we can say this is the orbital time. So orbital period we can say. So this is orbital period, time taken for this satellite to complete one cycle around this planet. So if you look at given options, it is given to the distance of the satellite from the center of the planet. This one is needed. So it means this one is correct, this is correct, this is also correct. So C is not answer. The radius of the planet, it does not depend on radius of the planet. Does not depend. So it means this is incorrect, this is incorrect, this is also incorrect. So this one is correct. Period of rotation of the planet around its own axis, it does not depend on that. So this is correct. Time for the satellite to orbit the planet, yes, this is true. So the answer for this question is B. Simply you need to understand the meaning of what is this distance and what is this time. T is the time taken to complete one cycle around the planet, and R is the distance between center of the planet to the center of satellite. R simply you can say from the center of the planet to the satellite. R we can say this is the orbital radius. So this term is also important. So R is orbital radius. Question 28 says, approximately how long does it take for the moon to make one complete orbit of the earth? Means time taken for the moon to complete one cycle around our planet, and that time is equal to 1 month, or simply you can say about 29 days. So the answer for this question is B. Question 39 says, the energy generated in stable stars comes from nuclear reactions. Which type of reaction occurs in the sun? So we need to understand fusion is taking place in the sun. Fusion. So fusion is very important. So we can say fusion reaction takes place in the sun, and sun is generating a lot of energy. So if you look at given answers, helium nuclei break up. No. Fusion means that smaller nuclei, they combine together to form a heavier nucleus. So in this case hydrogen combined, they form helium. Helium nuclei join together to form helium. So this is wrong. Helium, hydrogen is wrong. Hydrogen nuclei break up. No. Hydrogen nuclei combine. Hydrogen nuclei join together to form helium nuclei. So here we have hydrogen, so this is hydrogen, and here we have helium, so this is helium, and here we have hydrogen. So hydrogen nuclei combine together to form helium nucleus, and this process is nuclear fusion. So the answer for this question is D. Question 40 says, two quantities define the Hubble constant h0, the speed at which the galaxy is moving away from the Earth and the distance of the galaxy from the Earth. what is the relationship between V and D, and what is the current estimate for H naught. So Hubble law simply tells us that V is equal to H naught D. So from here we can say V is directly proportional to D. So this is one thing we need to understand. So if you look at given options, so answer can be A or answer can be C. B cannot be the answer, D cannot be the answer. Now we need to look at given values of H naught. If you look at option C, so this is telling us 3.0 times 10 to 8, and this is not value of Hubble constant, this is speed of light in vacuum or speed of light in air. So it means this is incorrect. So the answer for this question is A. We have done all the questions from this paper. I hope you will find this video helpful. If this video was helpful, please like and subscribe the channel, because your encouragement is very important. And also, if you have any questions from this paper or from any other paper, you can just leave your questions in the comments and I will try to answer as soon as possible. See you in next video.